Hi everyone, I'm Shiva Pranay. In this video, I will explain my project Event-Driven Order Processing System. This project is built using Node.js, Express.js, Apache Kafka, MySQL and Docker. The goal of this project is to understand how microservices communicate asynchronously using events. In this system, we have three services. Those are order service, inventory service and notification service, and they communicate with each other using Kafka events. Like as you can see, the problem in traditional systems is like servers communicates using direct API calls. Like when a user places an order, the the order service communicates to the inventory service, like to update the stocks or reduce the stocks. Then it returns a response it, that it has successfully updated or it fails to update. Then only the order service can communicate with the notification service. So the problem with this approach is that service becomes tightly coupled. Like if the inventory service is down, the order service might fail. It becomes hard to scale the system. So for this instead of services calling each other directly, they communicate using events through Kafka so that each service publish and consume events, which makes the system more scalable and loosely coupled. So the system flow as a first the client sends a request to the order service to create an order, and the order service saves the order in the database and publish an order created event. So in between there is a transactional events transactional outbox where an outbox event is maintained that whether the event is processed or not. So the order box worker will check the events, and if any event is fails to process, then it's republish those events. So the inventory service listen to this event, checks the stocks and updates the inventory. After processing it, it publish either inventory updated event if successful or else order failed event if stocks is insufficient. Finally, the notification service listens to these events and logs a notification message. So the project has three main folders. Those are order services, notification service, and inventory service. Each service has its own server file and Kafka logic and database connections. Like for example, each one has server.js starts the services, and Kafka consumer handles Kafka messages, and Kafka produces and is published events. The order service also use a transactional outbox, as I said previous, to safely publish events to Kafka. As you can see, the order service has producer, so it only publish an event wherein and there is an API endpoint. Order can be placed by using the post and can access the order to see whether the status is confirmed or not through the get slash ID of the order ID, and the outbox worker where he checks whether the events which are failed from the outbox events and only limits to 10. It then it processes all the events and checks whether the order is published or not, and later on it again publishes the events and updates the query. So this is everything to the order service. And while coming to the inventory service, it has both consumer and producer. Like consumer is used to read the events which was published by the order, and User is used to publish the response which was produced from the inventory service, and the main logic comes in the inventory service, whereas checks whether the e- whether it has event is processed or not. Like if it has two events with the same values and the same ID, it checks whether the first event was processed or not. If it's processed, it skips the event, and if not, it will process the event like updating the stocks, and then it updates the publish event, and it publish a response so that the notification server can get it by the consumer event. And here also it has a server.js where the service starts. It starts consumer checking whether any events is published or not. This is everything to the code base. Let's move to the running the project. Project we use Docker Compose. Like from the project root folder, we need to build. So there starts all the required services like Zookeeper, Kafka, MySQL, order service, inventory service, and notification service. It starts 6 containers. We need to wait as each service depends on Kafka and Zookeeper. We need to wait until the Kafka and Zookeeper are started running. We can check whether the containers are up or not by using the Docker PS. As you can see, then order service, notification service, and inventory service, Kafka, MySQL, and Zookeeper. 6 containers has been started. We can move of Postman, where we can place an order. As you can see, I will change the quantity to the 3, the ID of SKU, which is a stock keeping unit, to 2. Let's hit it. As you can see, we got an order ID placed as I copied the order ID. As I said that we have another endpoint that whether the status of the order, right? Let me place it here. As you can see, we got an order ID and the user who placed an ID and the items and the status of it. It's still pending and created and an update. You can see everything in the. As you can see, an order event has been published and notification order is also been confirmed and an update has been done. So what happens here is when the order service publish an event, the inventory service process it and updates the stocks. Then finally the notification server is logs the result. If stock is available, we see order confirmed, as you can see. Otherwise, we see order failed due to insufficient stock. So in this project, I implemented a Kafka-based event-driven microservice system. It demonstrates important backend concepts like event-driven architecture and transactional outbox pattern and item to consumers and a microservice with Docker. Thank you for watching.